If you create structural frames, this new application inside of NX called Structure Designer just may be your perfect application for design purposes. Our goals here are to create a machine frame around our conveyor system here. You can work in two ways. You can either build your machine first and then wrap the frame around it, or build your frame first and then hang your components off of it. So new in the application here, Structure Designer, if you go to your application menu and you go to More, you will see a new entry called Structure Designer. I already have the command added here for quick access. Once you add that that command, you will find commands for a new structure, construction commands, member commands, visualize, and a few other things. Also, there is a new navigator here just for Structure Designer. How the system works is in your top level assembly, the system will automatically create a subassembly to the naming of your choice, and anything that you create will automatically be placed in that subassembly. How you create this is with the new structure command. You specify the up direction, and I'll show you why you need that a little later on, your shapes catalog, and your name. Once you've done that, it will create the subassembly for you and automatically make that your active subassembly. Now, anything I add, whether it be sketches or members or specialty features like mounting feet, will automatically be placed in that and managed using the navigator. All right, so at this point, time to build our skeleton or our cage for our frame. There's a few ways that you can do this. You can use traditional sketching commands, or my personal favorite is the new frame command. All you need to do is click one time, a second time, and a third time for the actual height, and it creates the structural frame for you. If you want to add some additional members in here, these handles are at your fingertips, allowing you to click them, grab them, and drag them and copy them or move them to a different location. I am going to move these to about the midpoint of my frame. Once you hit apply, it puts you in the command again, so you can create another frame, whether it be on top or, in this case, on the very bottom of my machine, adding a small footrest. That constitutes the bulk of what I consider the cage for my frame here. What I might want to add is a couple of diagonal stiffening members, so I'm going to go ahead and add a few of those. We'll add maybe just one or across the front and maybe one across the back. So I'm going to use the line-to-line command, and I'm going to go from point to point and create a couple diagonal stiffening members. We'll convert these to 3D frames in just a few minutes. All right, now it's time to convert, or not convert, but create actual 3D members. So there's a member command up there that gives you access to the library and gives you access to what curves you want to turn into a 3D member. Our library is pretty rich. If I start at the top, go from angle equal, we have most things in steel and aluminum. We have different standards, whether it's DIN, EN, or ANSI if you're working in an English type template. Different grades of steel and tons of sizes for each one of our members. We also have unangle equal, channel, and as I drill down the list here, you can see that not only are we giving you a wide variety, but we're actually parameterizing these models. If you're not sure what the parameters are, just look at the icon and then look at the table of dimensions to see exactly what maps to what. Let's create a machine out of square tubing, and maybe around 60 by 4, and I'm going to simply pick the entire frame 2, and we'll convert all of those members or those sketch elements to a frame member for me. Now, as it's creating these unique members and adding them to my tree, the system is smart enough to know what side to add the material to. I have a rule set up that says always add the material to the inside, and the uppermost members, I want you to miter those and butt everything else. Hence why we needed the up direction. Now we have some very intelligent system that can kind of infer what you want based on some known geometric conditions. Now we put a miter at the top and we butted everything else. If you don't like that, I will show you how to change that in just a few minutes. Let's add some more members to the very bottom. Let's add some angle equal to the very bottom. So I'm going to simply pick the sketch. And first thing first is it's not the right size, so let's go ahead and change that size to something else, like maybe, I don't know, 45 by 3. And if you want to change the orientation, we have these handy flip buttons to flip about the X, flip about the Y, and even select an alternate origin if you want to snap various points to your the actual sketch itself. I'll put this right in the center, and that's probably going to be good enough, and we'll go ahead and pick more sketch elements. The system automatically applies those parameters to the next sketch element, so you don't have to sit and orient this thing every time. All right, last but not least, these diagonal stiffening bars. Let's go ahead and create maybe some round tubing for those. And I'm going to pick just some odd size here. I'm not going to really worry about the size at this point. Even if things are at an angle, we're automatically going to butt them and trim them off according to the adjacent geometry. All right, I think that's a pretty good start on our machine here. If you don't like these corners, like I said earlier, there's a couple things you can do. You can double click the corner itself, and it allows you to edit that corner, or there is an edit corner at the very top that you can make changes as well. So the what's listed in red is what you can control. You can change this to a miter or a butt or a cope, and we'll automatically butt everything else. If you want to reconfigure what gets butted to what, just simply pick that and move that up or down in the list to get a very, very different look and feel of your actual corner itself. So virtually anything that you want to create, you can control with this handy dialog. I think we're going to leave this to a butt. I kind of like that joint, and we'll continue on with the design process. So if we take a quick look at our navigator here, we've got all of these discrete members, and we have all of these corner types that are on here. And notice how we have the handy highlight that shows the exact child and parent relationship on what is managing what or what is controlling what. The members are a flat list, but if you want to sort of pack them, just pack them. And we will take any geometrically identical member and combine it together. Now, it is still a unique member on disk, but at least you can get an at-a-glance magnitude of the complexity of your design from the navigator. Also, if you want to see what members are what, there is a handy visual stock report that can be run that shows in color all of the tubes, all the round tubes, all the angle iron, and so on and so forth. Nice, fast way of seeing what your model is being made of. All right, I don't like that open cap there, so let's cap it off. We have a special command for that called the end cap. You can either place material inside or outside, and outside you have the option to preserve the overall length, so we'll actually trim the member back. And we will add a chamfer of about maybe 7 millimeters, and we'll simply pick that face, and the system will do the rest. And I'm going to hit the OK button. And we have our end cap, and notice how it trimmed the faces off there. All right, now if you want to stiffen some things up, we have a gusset command that does that, kind of like a corner stiffener. All you need to do is simply pick the faces, and the system does the rest. Now we have options for triangular with a nose, square, rectangular, and you can even control the parameters or the sizes of everything with this table of dimensions. You can even control the thickness, whether it goes to both sides, the inside, the outside, and you can even kick it over to one side or the other, depending on what your actual design conditions are. We'll rotate this over, and we'll add a couple more gussets to the inside of our model. That's probably going to be good enough for right now, a good stiff corner. All right, at this point, let's make sure our model is actually going to work or not run into our conveyor system. So what we're going to do, we're going to make our top level assembly our work part. We are going to go to modeling and then activate Animation Designer and hit the play button. So this shows any interferences that we have in our model. Now I put one in here intentionally just to show you the general design process on how to interact with your frame design and other things that you're building on or around your frame. Now obviously there's an interference there. The question is how easy can we fix that? So all you need to do is go to Structure Designer and go to the frame member operation, drag that out of the way above or however far you think you need, and it will reconfigure all the members, redoes all the corners, maintains the orientation of your member placement, and redoes any corners or gussets or whatever kind of features that you've added to your model here. All in pretty quick performance. All right, last but not least might be the addition of some mounting feet. So up on the top you have a place equipment We are going to be renaming this thing eventually, so just keep in mind that the icon and the command might look a little different by the time you start to use this thing. We'll place a couple of square mounting feet at the very bottom of our model. And the system will prompt me for dimensions for my, my individual model here, or my parameters. So for example, I probably want this a bit larger, so I'm going to pick a stock size of 200 by 200, and the system will reconfigure that part for me and add it to my assembly. It's also trimmed back that length of that member so it is no longer, so the overall height of my frame has been maintained. All right, last but not least, it's time to create a drawing of this thing. So let's go ahead and make our top level assembly active, and we'll create a drawing. I'm just going to pick a standard A2 size and do an isometric view. I'll change my scale to 1 to 10, and let's go for a trimetric view. And we'll place this somewhere on our convenient on our sheet. Now that our view is placed, let's add a parts list. I already have my parts list customized. It includes a cut length option, and you can see from the dialog or the table that as I highlight something, it shows you not only the member, but actually shows you the true cut length as well in millimeters. If you make frames, check out Structure Designer. Thanks for watching.